Hello mga ka-wisdom! Welcome to Wisdom is Power channel. Kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos na katulad nito. Salamat! Ngayon pag-uusapan natin the efficiency of a DC generator. The efficiency of a DC generator is defined as the ratio of mechanical input power to the output electrical power. So efficiency is equals to electrical power output divided by the mechanical power input multiplied by 100%. Another equation for the efficiency that is equals to output power divided by the output power plus total losses multiplied by 100%. So another equation for the efficiency that is equals to input power minus total losses divided by the input power multiplied by 100%. So let's have practice problem number 1. A DC generator delivers a 30 ampere current to a load at 120 volts by consuming 4,500 joules per second of mechanical energy. Determine the efficiency of the generator. So let us write all the given first. The load current is equals to 30 amperes. The terminal voltage is equals to 120 volts. The mechanical power input is equals to 4,500 joules per second. So we all know that 1 watt is equals to 1 joule per second. So meaning, yung mechanical power input natin na 4,500 joules per second is equivalent to 4,500 watts. So whereas to solve for the efficiency. So to solve for the efficiency, let us try to solve the electrical power. That is the terminal voltage multiplied by the load current. That is 120 volts multiplied by 30 ampere. That is equals to 3,600 watts. So the efficiency is equals to output power divided by input power multiplied by 100%. That is 3,600 watts divided by 4,500 watts multiplied by 100%. That is equals to 80%. Practice problem number 2. A shunt generator supplies 95 amperes at a terminal voltage of 240 volts. The armature and shunt field resistances are 0.2 ohms and 60 ohms respectively. The iron and frictional losses are 2,000 watts. Find the efficiency of the DC generator. So again, let us write all the given. The load current is 95 amperes. The terminal voltage is 240 volts. The armature resistance is equals to 0.2 ohms. And the shunt resistance is equals to 60 ohms. The iron and frictional losses is equals to 2,000 watts. So we are asked to solve for the efficiency. So for the solution, let us solve for the shunt current first. That is equals to terminal voltage divided by the shunt field resistance. So that is 240 volts divided by 60 ohms, and we will get 4 amperes. So since we already know the shunt current, we can now solve for the armature current, which is equals to load current plus shunt current. So that is 95 plus 4, that is equals to 99 amperes. So we can now solve for the armature copper losses, that is I squared multiplied by RA. So simply plug in our values, that is 99 squared multiplied by 0.2 ohms, that is equals to 1,960.2 watts. For the shunt field copper losses, that is equals to the square of the shunt current multiplied by the shunt resistance, that is equals to 4 squared multiplied by 60, that is equals to 960 watts. So the total losses all in all, that is equals to the 1960.2 plus 960 watts plus the iron and frictional losses of 2000 watts. So all in all, there are 4920.2 watts total losses. So the output power that is equals to terminal voltage multiplied by load current, that is equals to 240 multiplied by 95. So that is 22,800 watts. So again, the efficiency, the equation for the efficiency is equals to output power all over output power plus total losses multiplied by 100%. So substituting all the values solved, so that is 22,800 divided by the sum of 22,800 and 4,920.2 multiplied by 100%. So we will get the efficiency of 82.25%. Practice problem number 3. The full load losses of a 20 kilowatts 230 volt shunt generators are as follows. Field losses, 180 watts. Armature losses, 1,200 watts. Windage and friction losses, that is 550 watts. Iron losses is equals to 500 watts. Determine the efficiency at full load. So for the solution, so we will just sum up all the losses to get the total losses. So i-add lang natin yung mga 180 watts plus 1,200 watts plus 550 watts plus 500 watts. So lahat ng losses na yon, that is equals to 2,430 watts. So again, the equation for the efficiency is equals to output power all over output power plus total losses multiplied by 100%. So substituting all the values, that is 20,000, yung ating 20 kilowatts, all over 20,000 plus yung total losses natin na 2,430 multiplied by 100%, that is 89.17% for the value of our efficiency. For problem number 4, a shunt generator supplies a load with 106 amperes at 125 volts. The shunt field resistance is 31.2 ohms and the armature resistance is 0.11 ohms. Determine the armature copper loss, the shunt field copper loss, and the efficiency. So writing all the given, the load current is equals to 106 amperes. The terminal voltage is equals to 125 volts. The shunt resistance is equals to 31.2 ohms. The armature resistance is 0.11 ohms. So we are asked to solve for the shunt field copper loss, the armature copper loss, and the efficiency. So first we have to solve for the shunt current, that is equals to terminal voltage divided by the shunt resistance, that is 125 volts divided by 31.2 ohms, and we will get 4.01 amperes. So solving for the armature current, that is equals to load current plus the shunt current, so that is 106 plus 4.01 is equals to 110.01 amperes. Then we can now solve for the armature copper losses. So that is the square of armature current multiplied by the armature resistance. That is equals to 1,331.24 watts. And to solve for the shunt field copper losses, that is equals to the square of the shunt current multiplied by the shunt resistance. So that is 4.01 squared multiplied by 31.2 ohms. That is equals to 501.7 watts. So for the efficiency, we will solve for the total copper losses, that is 1,331.24 watts plus 501.7 watts, that is equals to 1,832.94 watts. So the output power is equals to terminal voltage multiplied by the load current, that is equals to 125 multiplied by 106 amperes. So the output power is equals to 13,250 watts. And to solve for the efficiency, that is equals to output power divided by the sum of output power and the total losses multiplied by 100%. Then substitute all the given values or the solved values. Then the efficiency is equals to 87.85%. Problem number 5. A shunt generator delivers 195 amperes. Terminal potential difference of 250 volts. The armature resistance, and shunt field resistance are 0.02 ohms and 50 ohms respectively. The iron and friction losses equals 950 watts. So find A, the EMF generated, B, total copper losses, and C, efficiency. So for the given, the load current is 195 amperes. The terminal voltage is equals to 250 volts. The armature resistance is 0.02 ohms. The shunt resistance is equals to 50 ohms. The iron and friction losses is equals to 950 watts. So we are asked to solve for the generated EMF, the total copper losses, and the efficiency. So to solve for the generated EMF, that is equals to terminal voltage multiplied by the armature current multiplied by the armature resistance. So that is, let us solve for the shunt current first. That is terminal voltage divided by shunt resistance. That is 250 divided by 50. That is equals to 5 amperes. And to solve for the armature current, we simply get the sum of load current and the shunt current. That is equals to 200 amperes. So now we can solve for the generated EMF. That is 250 plus 200 multiplied by 0.02. So the generated voltage is equals to 254 volts. And to solve for the copper losses, first we solve for the armature copper losses. That is the square of armature current multiplied by the armature resistance, which is equals to 800 watts. And for the value of the shunt field copper losses, that is the square of the shunt current multiplied by the shunt resistance, that is 5 squared multiplied by 50. So that is 1,250 watts. So the total copper losses is the sum of armature copper loss and shunt field copper loss. We just simply add them and we will get 2,050 watts for the total copper losses. And to solve for the efficiency, let us solve for the output power, that is terminal voltage multiplied by the line current. So that is 195 amperes multiplied by 250 volts. That is equals to 48,750 watts for the output power. And but the total losses is equals to 2,050 plus 950. That is equals to 3,000 watts. So now we can solve for the efficiency using our equation, output power divided by output power plus the total losses multiplied by 100%. So substituting all the values given, then the value of the efficiency is 94.2%. So that's all mga ka-wisdom. Again, kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos na katulad nito. Salamat!